This is a continuation video from where we just had the last one. We milled the prior to this. Look at the video for doing the cylinder head, milling down the top surface and do the two slots on the side. Do that stage first before you start this process of looking at creating the brackets. These are the brackets, and the brackets fit into the side of the part nice and neatly. It's important that we get these done correctly, so that we have a nice arc here in the finish, and everything has to line up. So the holes we drilled here are going to match up with the holes we drilled on our cylinder head. So we want to make sure that they're in line, that they're not out of alignment. So they are crucial. So we start off, you get your material again from the store. You get your material, the finished length of the part, looking at our drawing, it's 61. That material is probably cost around 64, maybe 63 millimeters in length. What we're going to do first off is face off one side, and we're going to drill the holes, and then we're going to turn around to bring it to its final length, 61, and then finally we're going to create the arcs. So the list of tools for this job, again, get them from the store, down the toolbox. To start off, to do the facing off of your piece, you can use a diameter anywhere between 10 to 20 millimeters end mill. Either one will do. And the purpose of it is just to face off the end of the part. You need an edge finder, a spot drill those two holes. The first hole is 5.5. It's in 10 millimeters. The second hole then is located incrementally from there, and it's up 51, and that is still with a diameter 8 millimeters. And then finally, the last two you're going to need is the radius cutter for creating the arc on top. That's a 6 millimeter radius cutter because the width of the material is 12. So you get a parallel. It's important to get your parallel, and make sure the parallel you get is not wider than the two pieces of metal. It's ensured that the material parallel you use is at the correct height and width, so that when you put the parallel in and you rest the parts on the parallel, that when you close the jaws of the vise, it closes on the material and not on the parallel. So allow a slight overhang of your part, about 15 millimeters over the edge of the part, and you just tighten up in that vise. And in the chuck at the moment, I have in the spindle, I have a 20 millimeter end mill. I'm going to use that to face off my material. So dropping down the quill to the height, locking it, powering on the lathe, and adjusting my speed for that diameter. So I'm not going to use the speed here, it depends on what size diameter cutting tool you have in. If it's a 10 or a 20 or a 12 or a 15, you adjust your speed accordingly, and I'm going to do that here on my own. Right, just in, I'm going to manually go in then, and you're going to listen to the sound as we touch the end of the part. You'll hear it making cut. We're now touching the part. I'm just going to face across both plates at the same time. We're doing both at the same time because we need two brackets. So we're just checking there now. Let's stop the lathe. I can clearly see that we're going to have a nice clean surface here, and then we can square it up nicely. So that's all you need to do with that end mill. You can now remove that out. And we're going to start drilling the holes. So we're using our Jacob's chuck, back in again. And you're adjusting down the knee of the machine to let the chuck in position. So you're going to need the edge finder again. So winding over. Pause.
Yep.
So I'm going to pop in my edge finder into the chuck and tighten that up. Now we're going to find the X here. We're going to find the center of the tool, and which is the center of the machine, the X, and zero that, and the DRO, and the same process for the Y. So to use the edge finder, you're going to do the X, you're going to drop down again, and you're winding in, making sure it's flicked off center before we start the machine. So the guard are on the machine, and you're driving in then to ensure you keep going in to the point where it's sort of flicks off. Just there, zero your X. Now we're 3 millimeters from the center of the machine, so we have to move in 3 in our DRO, your X axis. In 3, and then again 0 your X. Stop the machine. Now repeat the process now and pick one of the jaws, either this one here or the outside one there. So drop into the pocket between devices, power on the machine, and then drive over and touch off the edge of the vise till it picks off. That's the point. Zero your Y. Up. Again, move in the 3 mil to align the center of the tool over the edge of the vise. and 0. Now, that's the edge finding done. So when you pop in your spot drill, you tighten up the chuck. You may need to wind or adjust your knee dial to get the tool into position. So when the tip of the spot drill is over the edge of the part, we should see 0, 0 in our coordinate position if everything's done correctly. So as you're over the edge of the part, the tip of the drill bit, which is the centre of the machine, is reading 0, 0, 0 in the coordinate position, which means we're in the correct position. So it's correctly been edge found. So we've aligned the centre of the machine over with the coordinate part and the edge of the part. So now, the location for the holes, refer to your drawings, take your time and make sure you drill these holes correctly. So the location of the hole is halfway between 12, so it's in 6 in the Y, and the location for the first hole is in 10, then the second hole is in 51 from that edge. This is your reference edge, we want to call it. This is the reference machine edge. So we've got a reference machine edge here, which is the edge we're using here. This is the same edge we're looking off. We're drilling the first one in 10, which is 5.5, the other hole is diameter 8. So moving in a Y direction in 6, the Y, that's the centre point, and then in 10 for the first location, first hole. In position, go to the lock, power the machine, and then you're going to spot drill the first hole. You spotted the first hole, just a gentle pilot hole. That's the first one done, and I'm going to move into the second coordinate position now. So while the spot drill is in position, drill the second hole, which is in 51. Open your quill and drill down again. Now, the spot drill is finished with, I'm going to place out, and the first one I'm going to drill is going to drill the 5.5. So my first hole, I'm going to drill 5.5, the second hole I'm going to drill diameter 8. So I have my drill bits ready to go. 5.5, place out the spot drill, and pop in the 5.5 drill bit. Again, you may have to adjust your knee of the machine to lower it slightly. Now, before you drill, you're going to drill down through the part, so we need to make sure that before we remove the parallel, which is underneath the brackets, ensure that, again, that parts are held securely, and then you can slide out that parallel, which is underneath supporting the brackets. That parallel can be moved out slightly out of the way, as you do not need it now. So you can slide that out of the way. That's now taken out of the way. So when you drill down, you're not going to drill down through the parallel. So move into position. X10 again. And the Y has not changed. So I'm going to lock my Y because we don't want the Y to change down stage. Just our X position coordinates is moving. Powering on, opening the quill, and you're drilling down, taking your time. And I'm drilling that there about 1500 RPM. You're drilling down through it. That's the 5.5. As you stop the machine, don't remove the swarf, only using your brush, don't use your hands, you don't want to get cut. So 5.5 is done, and the next hole, according to our drone, is a diameter 8. So diameter 8 drill bit is ready to go. I'm going to try and pop that in. I'll need to adjust my machine down slightly in the knee dial to fit the drill bit in. So I have them adjusted the Y, and now we're going to move to the next coordinate position. And the new coordinate position, according to our drawings, always check your drawings, wherever you're drilling this part, in your booklet, just so I have on screen the replication for that. And the next location, the next hole that we can see is diameter 8, and it's 10, 41, is 51 to the next location. So move into position. Which is your 51. So you're in position at 51. Power on your lock up adjust your speed again to suit. And then you're drilling down to diameter 8. That's that done. Again, remove the swarf from the drill bit using the brush. Now I've left the coolant off for this purpose. What we're doing here. So that's now done. And just be careful, make sure you're using the coolant, the drill bit does not get hot. So then, as you were saying, that's the holes now drilled, and then the next stage of this process is to bring it down to the correct final size, which is going to be 61. Move out your plates. Up now, we no longer need it. And I'm going to pop back in my diameter 20 end mill that I had previously used to square up the pieces. Push back in your end mill. And now what we're going to do is pop back in the parallel we had. We're using, taking your two plates, and it's the opposite end now. That's the side we've already machined in the red. Now we're going to machine the opposite side now, the two saw cuts we can see on it. I'm bringing the final length down here to 61. So to ensure alignment, what can we do is you can use your diameter 8 drill bit that you have there, or the 5.5. And you can do is you can pop the drill bit through the brackets to ensure that they're both in alignment. And as you're lining them up then, it's easier then to hold the parts and position them, and they're squared up a lot easier. Just a little trick that you can do to ensure that both ends this end are matching up nicely, and then you can remove that out to hold in position. What you want to ensure here is that both the 5mm drill bit and the 8mm drill bit are fitting into both pieces, so you can tell that they're both in line, two holes are in line, as you face off these two parts. So what we're going to do now is we're going to bring up the bed of the machine closer. We're closing over, we're dropping down then with the quill the rest of the way into those parts. So you're ensuring then that you're down to the correct depth, that you're catching both plates with the same cut. Power on your milling machine, and now adjust your speed accordingly to your diameter of your cutter, whichever one you're using. If it's a diameter 20, 10 or 12. Now we're just going to square up the plates. We're just cutting it there now, making a cut. I'm opening up my lock and my y-axis. I had it locked, previously had it locked. Face off the pieces, and you're just ensuring now as you stop that you have a squared up end before you take a measurement. So we've just made a cut, so I'm going to zero my y-axis, and now I'm going to take out my vernier calipers to measure the full length of the parts. I think, now depending on your part when you measure, I'm measuring 64.73, so I'll have to remove 3.73 off the parts to get it down to 61. So what you do there is, you won't do it fully in one pass, you'll do it in multiple passes. Power on again your machine. So the intermittent lock, and as you power on, you're adjusting here now. So as your X reads 3.43, you've taken off the right amount of measurement. Now, apologies there. What I'm going to do is just, if at any stage, you're just facing off across your piece. So I've squared up the pieces, just to recap what I've done. I've squared up the pieces here. I'm zeroing the X. I'm stopping the machine, and I just want to double check before I remove this material that I've measured it correctly. So I'm just checking there. 64.74, so I have 3.73 to come off. So when the X reads 3.73, that will leave me the edge of the tool I've used as almost like an edge finder now. And when I've taken off 3.73, I'll be left with the full length from here to here has been 61. Powering on. I'm going to adjust in now, half a millimetre at a time. I have 1.5 taken off. I'm watching that X number that comes down to suit me. It won't all be the same when you do it. That's the purpose. That's the whole, in the principle, how it works. You're facing off across. I have 2.99. I'll adjust in again. And now this will be my last cut. I got 3.2, so I'm going to adjust into 3.73, which will give me my final number there to be 61 total in length. As I face across this piece, this is my final cut. And now the finished length of the part is going to be 61. So that's that stage done. And we now got 61 final length of our parts there is at 61. Perfect. 61 is achieved. And now we're going to, at this stage, the holes are drilled. We have them down to length. And now you can remove the brackets out from the... So you have the 2 holes drilled, 5.5, diameter 8, and a length of 2 parts is 61. The recap we did at the start, we faced off one side, then we used the edge finder to find the center of the machine, and that allows us in the X and Y coordinates, that allows us to drill the hole here for the 5.5, the diameter 8. Then we took it out, flipped it around the opposite side, faced off with the cutter, zeroed the DRO, and then we measured to see exactly what the length of the part was, and then we machined down to give us our finished length of 61, and that's where we're at now. The next stage is going to move on now. It's going to use what's known as a radius cutter. So the radius cutter has been used with this tool here, and that's to create the perfect arc onto our part. And to use this tool, as you watch it from the first time, the tip of the tool there corresponds to the tip of that point there on the sketch, and the corner of the tool there corresponds to the corner of the arc. That's a 6mm arc, and we want to create a 6mm arc onto our part. So to do that, what we're going to do is we're going to bring in this part of the tool and touch off. That's going to be the coordinate in the X. So that's going to be our coordinate in X, and then we're going to move out this distance here of 6 and set the height from here down off the top surface. So when that tip hits here and the corner tool hits here, it'll form an arc onto the edge of our bracket. That's the proper working. So to do that, we get set up first. I need to remove out this tool we're using, 20mm, and replace it out with the 6mm radius cutter. That comes out. I'm going to use the collet from that tool for our radius cutter and place it back in its holder. So I have left myself with about that much of a gap that I can fit my fingers in as I'm holding the tool. So insert it up and draw it in. Now, the procedure to set the brackets is we want to ensure that they're vertically up the way, and what we're trying to do is create this nice even arc onto our brackets. So we're trying to create this even arc onto our brackets using this tool here, the radius cutter. So if we can see there, and zoomed in, we can see we're going to create that arc with the radius cutter. So what we're going to do is we're going to line the parts up with the edge. I'm going to use my 5.5 drill bit as a guide to ensure that both brackets are lining up. So making sure that the drill bit goes through both parts, therefore we have the same hole alignment, and then slot the brackets into the vise, and then use the edge of the vise as to ensure that they are vertical. These two jaws of the vices have been perfectly ground, and then you're ensuring then that the parallel keeps you level and square the brackets are upside down. So you have a slight overhang on top, and then you're keeping them perpendicular to the cutter using the edge of the vise. Tighten them up, and now I'm going to just edge find on one side. I'm going to use the radius cutter now. So what we're going to do is we're going to bring in the radius cutter. we need to drop down. As I mentioned, I'm going to touch the edge of the tool off the edge of the part. It's not the corner of the tool is touching the corner of the part. I'm zeroing my X. So that corresponds here to, I've now aligned this tool up with the edge of the part. So that's found 0. And now I want to set the height off the top. So to do that, I move out the distance of the radius cutter, which is 6. I'm going to come just shy of that, just short of it, 5.8, and drop down to set the height. So that's setting my height there now, and it sits, so the top of the tool is touching the top of the part, and then we close up the vise, so when the radius cutter reaches in here, that will form the perfect arc we machined off this side. So you do the first side, and you go around and do the pass on the opposite side. So firing on the cutter, adjust your speed down to suit around 830 RPM. So adjusting in, and then you're machining it back and forth across the part. Around 580 RPM. Vibration in the parts as the material is very light. As the material is very light, you can hear a bit of vibration in the metal as it's being cut. We've got 1 mil left to cut. I'm watching the X number here as that has closer to 0. I haven't adjusted my height at all. I'm just moving in the X and then machining back and forth across the Y axis. So I have half mil left to go. 0.2. And then the final one, I'm just going to stop shy of the 1 of the 0, about 0.1 off it. And that's the first side done. So we can clearly see there, up close, that when we stop, that we have the first created the corner of the arc. Now we repeat the process on the opposite side. So again, come in, we need to come up, adjust in to get our X coordinates first. So bring the tool over until it touches the corner of the part, 0 your X, then removing away the width of the tool, which is 6, and you're dropping down to set your height. And the height has been set. Height has now been set. That doesn't change. You're going to power on the cutter and you're working your way back in now. Or basically using on this side, you're going to create the arc on the opposite side. Small bit of vibration as those parts are quite light material. Only 0.8, half a minute away from the final cut. And 0.1 to go. Now, with the parts faced off, again let's stop the machine. And we can see there we've created the arc on the opposite side as the cutter is finished in. So now, before you move it out from the vise, it's always a good idea now at this stage is just to file off that section, smooth off both parts at the start, and just get a small file smooth file just to ensure that they're nice and smooth before you take them out. So you're just going to smooth up both sides of the surface. And then you're just cleaning up those corners with the file. Also, you can use a smooth file or a round half file if you have them. You can get one from the store. And you're just making sure that those two parts are squared up nicely together. So we can see there now they're taking shape nicely. So you're going to repeat the process that we just created there on the opposite sides. So that's one side completely finished, and you need to repeat that same process on the opposite side. So exactly what we just did there, you're just going to repeat it, pop the parts into the vise, again using your parallel to hold them in square. Don't have them up too far out of the vise, trying to avoid as much deflection and vibrations of the cutter as you can kind of hear. So ensuring that the two parts are sitting nice and square up out of the vise. We want to put their drill bit through first of all to ensure they fit, and then using that then as a guide to ensure that they sit in nicely. And then you're going to repeat the process. I'm just tap them down as close as you can into the vise. Don't have them hanging up too high out of it, because otherwise they'll deflect. There'll be a lot of vibrations. So the closer they're in, the better their noise and sound. So that's that part. You're going to repeat the process that we just did there on the opposite side, and then that's them two parts. So then you take them out and they're done. You move them from there and you go up to your parts. They'll fit nice and snugly as they are doing there, right into the parts. So actually, those both parts are actually just totally perfect for what we want. And the alignment is perfect on the hole, which means when you get your screw, everything is lining up. You follow the procedure. Thank you very much. That's all the steps for those videos.